Hi everyone. I'm going to discuss evaluating a 3 by 3 determinant. Now, in evaluating a 3 by 3 determinant, we're going to consider minors. Now, to each element of a 3 by 3 matrix, there corresponds a 2 by 2 matrix which is obtained as we delete one row and one column of that element. And the determinant of the 2 by 2 matrix is now what we call as the minor of that element. So you learn how to calculate for the determinant of a 2 by 2 matrix in our previous discussion. So basically what we're going to do is in evaluating a 3 by 3 determinant is to come up with calculating the 2 by 2 matrix, and that is working on the minor first of the given element. So what we're going to do for now is to find the minors, for example, for the elements 2, 3, and negative 6 in this 3 by 3 matrix. And as you can see, 2, 3, and negative 6 are elements of this 3 by 3 matrix. Now, we're going to work on the minor first for the element 2 in this 3 by 3 matrix. So from the definition, we're going to obtain a 2 by 2 matrix, and which can be done by deleting a row and a column wherein this element 2 belongs. So we're going to delete this row and this column. So we got four remaining elements, and that is evaluating 2 by 2 matrix, which is now called as the minor for element 2, for example. So we have negative 2, 3 here and negative 6, 7. So evaluating the determinant of a 2 by 2 matrix is done by working on the cross product, difference on the cross product of the two factors, negative 2, 7, and 3, negative 6. We know that this is negative 14 and this is positive 18. So the minor for element 2 here is 4. Okay. Now, to find the minor for 3, we're going to delete the second row and the third column, since 3 belongs to the second row and the third column. And there remains 4 elements, which is actually a 2 by 2 matrix. And calculating for the minor for element 3 is done by evaluating the determinant defined by these elements, by this 2 by 2 matrix. So we have product of 2 and negative 6 minus product of negative 1 and 4. So this is negative 12 plus 4. So this is equal to negative 8. So the minor for the element T is negative 8. Now, finding the minor for negative 6 requires us to delete the third row and the second column, since negative 6 belongs to this column and row. Okay? And then we will evaluate the determinant of this 2 by 2 matrix for us to calculate the minor for element negative 6. So we have product of 2 and 3 minus product of negative 8 and 0. And we know that this is 0. So the minor for element negative 6 is 6. So this time, in relation to evaluating 3 by 3 determinant, we're going to work on this formula. So the determinant for a 3 by 3 matrix is defined in terms of the determinants of minors. Okay. Now, writing the determinant of a 3 by 3 matrix in terms of minors is called as expansion by minors. Now, in the definition, we expanded by minors about the first column. So we consider the first column. Now, in evaluating the 3 by 3 determinant, in evaluating the determinant for a 3 by 3 matrix, we need to consider either a row or a column. In this definition, we have considered one column, and every column in a row uh, is composed of three elements. For example, if we're going to consider the first column, so that involves elements a sub 1, a sub 2, and a sub 3. And look how we expand by minors. So calculating for the 3 by 3 matrix is defined by, so we come up with three terms here represented by each element of the column or the row that we have selected. And each element there will be multiplied to its corresponding minor. And we know that the minor is computed by working on the determinant of a 2 by 2 matrix. So we will be leading to a 2 by 2 matrix as we remove one row and one column. Okay? And let us also be sensitive on the operation that we're gonna use. Here, this is plus, right? So this is followed by the pattern plus, minus, plus, separating each of these three terms. And this is actually summarized by the array sign represented by plus, minus, plus, minus, plus, minus, and plus, minus, plus. Since in the definition, we have made use of the first column, so this will be the sign array that we're going to consider plus, minus, plus. Okay, so I think we are now ready to evaluate the determinant of a 3 by 3 matrix. So find the determinant of the matrix by expansion by minors about the first column. So we're going to consider the first column. So here, the determinant is equal to, so we're going to consider the first column. So the first term would be 2 times its minor. So, of course, we're going to remove the first column and the first row where 2 is located. And we have negative 2, 3, negative 6, 7. And then take note that the sign that we're going to consider is plus, minus, plus. So the second term would be a minus sign followed by the second element a sub 2, which is 0. Although we know that any expression multiplied by 0 is 0, but let's just write this as is for us to see how we substituted each value in the formula. And we will multiply the second element by its corresponding minor. And if we write this 3 by 3 matrix, we have 2, 0, 4, negative 1, negative 2, negative 6, negative 8, 3, and 7. And then we will remove the second row as well as the first column where 0 is located. So there remains four elements which belongs to a 2 by 2 matrix. And we have negative 1, negative 8, negative 6, 7. And then finally plus the third element 4 times its minor. So if we rewrite again the 3 by 3 matrix, so we have 2, negative 1, negative 8, 0, negative 2, 3, 4, negative 6, 7. And we will eliminate one row and one column where 4 belongs. So we will eliminate the last row and the first column. So we have negative 1, negative 8 here. And then we have negative 2, and then we have 3. So simplifying the expression, we have 2, and then performing on the determinant of this 2 by 2 matrix, we have negative 2 times 7 minus 3 times negative 6. So this is minus 0 times negative 1 times 7 minus negative 8 times negative 6, and then plus 4 times negative 1, 3, minus the product of negative 8 and negative 2. So this is 0 now. And then this is equal to 2 times. So this is negative 14 plus 18. So this is 4. And then this is 0. So this is 4. So this is negative 3 class minus 16. So this is negative 19. So 4 times negative 19. So what is 2 times 4? What is 2 times 4 plus 4 times negative 19? So we have negative 68. So negative 68 as the value of D. Okay, for number 2, we have here, evaluate the determinant of the matrix by expanding the minors about the second row this time. Now, in evaluating, let me remind you, in evaluating the determinant, you can use any among the rows or the columns. It's just that in example, we're instructed to select the second row. Okay? So, D is equal to negative 2 times its minor. So, we're going to remove second row and first column. So, there remains 3, negative 5, 7, and 9. And then, since second row, so the sign must be negative plus negative. So, there should be a negative operation prior to negative 2. So, this is like, okay, okay, there. And then plus. And then the second element is 4 times its minor. So, we have 1, 3, negative 5, negative 2, 4, 6, 0, 7, and 9. And then we're going to remove the second row and the second column where 4 is located. So there remains 4 elements, 1, negative 5, 0, and 9. And then minus the last element 6 times its minor. So we have 1, 3, negative 5, negative 2, 4, 6, 0, 7, 9. And we will remove the last column and the second row. So there remains 1, 3, 0, 7. And then let's evaluate. So this is now 2 times, we have 3 times 9 minus negative 5 times 7. Okay, so either you use parentheses or this symbol, okay lang. Plus 4 times, this is 1 times 9 minus negative 5 times 0. And then minus 6, we have 1 times 7 minus 3 times 0. And then we have, this is 27 and this is plus 35. Okay, so we have 27 plus 35, 62. So this is 2 times 62 plus this is 9 and this is 0. So this is 4 times 9 and this is 7. This is 0 again. So negative 6 times 7. And D would be 2 times 62 plus 4 times 9 minus 6 times 7. So it's 118. Okay? So number 3 example. This time we're going to choose the simplest row or column. So the simplest column should be this column since this involves zero. And we know that it's easier for us to multiply an expression by zero. So we can easily work on the determinant of this 3 by 3 matrix. So we have D, and we're going to consider the sign positive, negative, positive. Okay? So this is 0 times, so we're going to eliminate this row and this column. 4 times negative 6, 7 times 9. And then minus 0 again. So this will be canceled and this. So this will be the elements that we're going to consider. 3, 5, 7, 9. And then plus 2 times. So this will be canceled. So we're going to consider 3, 5, 4, and negative 6. Well, this is 0 and this is 0. So your D equals 2 times 3 times negative 6 minus 5 times 4. So D equals 2 times. So this is negative 18 while this is 20. So this is negative 38. But we have to note that this is negative 5. So we have to do the necessary correction. This is negative 5. So this is plus 20 now. So this is 2 instead. So this is positive 2. So D equals 4 here. Now, you know how to evaluate for the determinant of a 3 by 3 matrix. This is related in our next discussion since we will be working on the solution for the system of linear equations in three variables, and we will be using the determinant. So in the previous discussion, you learned about Kramer's rule and we evaluated um, the value of the x and the y, which is the solution for a consistent and independent system using Kramer's rule. And I've introduced solving for the determinant as well as solving for x and y, which is obtained by working on d sub x and d sub y. In the next discussion, we will be doing the same manner. It's just that we will be adding another variable. So we will be working on three variables and we're going to consider solving for the determinants of a 3 by 3 matrix. So at least now you have the idea on how to work on it. So we will just continue next meeting as we evaluate for the solution of the system of linear equations in three variables using the determinant. So bye for now.